Welcome back, gentlemen. It's good to see you again. No, I can't really see you on the video here. Anyway, we're going to continue on with the next part of Chapter 8, Section 3 of Simplifying Radical Expressions. And today we're going to focus on simplifying radicals and simplifying products and quotients of radicals with different indexes. So let's talk about simplifying radicals first. There are some conditions that have to be in place before we can do any simplification of radicals. First, the radicand has no factor raised to a power greater than or equal to the index. The radicand has no fractions. No denominator contains a radical, and exponents in the radicand and the index of the radical have no common factor except 1. Okay, so the square root of 32. So the largest perfect square that goes into goes into 32, I should say, is 16. So we can break this up into two parts. I usually just skip right from here to here. So the square root of 16 times the square root of 2, and we get 4 square root of 2. The largest perfect square that goes into 300 is 100. So again, I just skipped that second step. And we get the square root of 100 times the square root of 3, which is 10 square root of 3. The square root of 35. There are no perfect squares that go into 35. Therefore, we're not going to bother. We're just done. You just say cannot be simplified or just write simplified on any quizzes you may take or tests. All right, the cube root of 54. The largest perfect cube that goes into 54 is 27, right? 3 times 3 times 3. So that would be equal to the cube root of 27 times the cube root of 2. And we end up with 3 times the cube root of 2. The largest perfect square that goes into 243 is again, or excuse me, not perfect square, perfect fourth is 3 to the fourth, or 81. So that would be 3 times the fourth root of 3. Okay, so let's do some problems here. And what I would suggest is you pause. I'll tell you when to pause, and then try the problem on your own, and then hit play to continue with the video. So the first one we're going to do here is the square root of 24. So the square root of 24, the largest perfect square that goes into 24 is 4. So that would be the square root of 4 times the square root of 6, which would then be simplified as 2 root 6. The square root of 108. Oh, I forgot to tell you to hit pause. Go ahead and hit pause. And welcome back. If you didn't hit pause, that's going to sound really weird. Anyway, the largest perfect square that goes into 108 is 36. And you kind of have to, check them to see what goes in with what, right? 36 times 3. Basically, you can look at this and say, well, 100 doesn't work, 81 doesn't work, 64 doesn't work. What's the next one? 49. That one doesn't work. And just work your way backwards. So 36, square root of 36 is 6. Square root of 3 is 3. Square root of 10, already simplified. I'm not going to ask you to hit pause on that. You should be able to see that right off the bat. You're going to recognize those. Let's try this one. I'll tell you to hit pause. Cube root of 16. Go ahead and hit pause, and I'll be here when you get back. Okay, you're back. Okay, so the largest perfect cube that goes into 16 is 8. So cube root of 8 times the cube root of 2, that becomes 2 times the cube root of 2. And finally, the last one, negative fourth root of 162. Well, 81 is a great fourth. Oops, sorry. Here, pause. Okay, come on back. All right, so the fourth root of 81, 81 being 9 times 9, which is also made up of 3 times 3. So then that's kind of your hint there. So a fourth root of 81 times the fourth root of 2. So you're going to end up with negative 3 fourth root of 2. All right, let's do one more example before I totally mess you up here. Cube root of negative 8x to the fourth, y to the fifth. So basically this is the cube root of negative 8 times the cube root of x cubed times the cube root of x, or times, yeah, just the cube root of x, times the cube root of x times the cube root of y cubed times the cube root of y squared. I'm just taking 3's out. So cube root of negative 8, negative 2. Cube root of x cubed is x. Cube root of y cubed, cross them out. Cube root of y cubed is y, and so I would have the square root of cube root of x y squared left. Okay, so if m is an integer, n and k are natural numbers, all indicated roots exist, then k to the n over the a to the km is equal to a to the nth root am. So basically this would become the 12th root of 2 cubed. Well, that's the same as 2 cubed to the 1/12th power, which is 1/4. So that would just turn into the 4th root of 2. So how can we get from here to here? We divide 3 into 12, get 4, 3 comes out. Over here, the 6th root of t squared to the 1/6, which is 1/3, so it becomes t to the cube. The cube root of t, excuse me. All right, let's try again. Well, this becomes 5 to the 6/9, right? Which is equal to 5 to the 2/3 power, which is equal to the cube root of 5 squared, which is equal to the cube root of 25. Okay. We have 4 to the p squared. Okay, 4th root of p squared. Well, this is equal to p to the 2/4, which is equal to p to the 1/2, right? We did this before, which is equal to the square root. Well, we don't even need to put that 2. This is the square root of p. Okay. Last part. Simplified products and quotients of radicals with different. Where did they go? So that's it for today. Go ahead and work the problems that we will be assigning for homework. Good luck. Have a good day. Oops.